Welcome to February 17th LeetCode Challenge. Combination sums. Given an array of distinct integers, candidates, and a target integer target, return a list of all unique combinations of candidates, where the chosen number of sums to target, you may return the combinations in any order. The same number of may be chosen from candidates and a limited number of times. Two combinations are unique if the frequency of at least one of the chosen number is different. It is guaranteed that the number of unique combinations that sums up to the target is less than 150 combinations for the given input. So we're given this array of integers, distinct integers, let's say, called candidates, and we want to sum of the target 7. So how could we make the sum of 7 from any particular unique combination of candidates? So we start off with, and we could choose any number within the array any number of times. So first let's choose 7 once. That would be a good option. And then we choose 2, 2, then 3, which also makes 7. So the candidates are 2 and 3, where you have 2 plus 2 plus 3 equals 7. Note that 2 could be used multiple times. And then 7, you pick that once, so 7 equals 7, therefore there's two combinations. In this example, you have the array of distinct candidates, and you want the target to be equal to 8. So how are we going to go about making the sum of 8 from any of these candidate integers? Well, you could choose 3 and 5, which make 8. You could choose 2 and 3 two times, so 2 plus 3 plus 3 equals 8. Or you could choose 2 4 times, where you have 2 plus 2 plus 2 plus 2 equals 8. And a third example here, so you have the candidate equals 2 and target of 1. There's nothing that can make a sum of 1 from the candidates of 2. So you return empty. So the list of the length of candidates up between 1 to 30. Each index, each value of candidates is between 1 to 200. All elements of the candidates are distinct, and the target is between 1 to 500. Alright, so there's a couple ways of solving this. You could use a depth first search. We could use recursive algorithm to search through the list and then find it that way as well. I think we could actually use a dynamic programming approach for this. So I guess the idea is to create a temporary array of length 1, length of target plus 1. So then we use the element of the index I to store the possible combination, the sum of the I. And that's pretty much the idea. So let's kind of go about doing that. So we're going to make a dynamic programming array. So that's going to be an array for blank in the range of target plus 1. Alright, this should be what we need. And then the dynamic programming array is going to be at index 0. It's going to be initialized to an empty array, an array of an array. Oops. There you go. And then we're going to do a couple for loops here to iterate through the candidates. So for, say, C in candidates, we are going to loop through each element, call element I, in the range of C till the target plus 1. And then within that, we're going to find whether we can make the sum or not. If we can, let's just so basically the dynamic program is going to take a various paths. So for instance, if you're on step number 1, if you can take a path that adds you equal to the sum, then you want to add that to your dynamic programming array. So let's call this path. For each path you take in the dynamic programming array, where it's going to be the index I minus the candidate, you are going to add the dynamic programming index I and append, and you're going to append the path that you're taking, so path plus the candidate that will equal to the sum, target actually, will equal to the target. And then for all this, you want to return the dynamic programming array at the last index. dp -1. Alright, let's see if this works. Target. There. Alright, seems to be working. Submit it. It gets accepted. Awesome. So time complexity will be big O of n times n. I'm just going to go round up here and say that time complexity is big O of n cubed. And for space complexity is big O of n squared, because we have a dynamic programming array of an array of an array. Alright, there you go. Have a great day, guys.